or comments or concerns? Say again? Oh, all right. So, one of the first things I'll point out is this. Yes, you are allowed to use your calculator as we are sorting. However, when it comes to the number sets, you should not need a calculator, especially on assessments. In fact, sorting numbers according to their number sets will be something that is on a non-calculator portion of the test, okay? So, you need to make sure that you are now starting to think through how do we identify even when I don't have a calculator available. So let's get into today's lesson with all that. So we're going to continue sorting the complex number system. This will take up hopefully no more than 30 minutes, and then we'll get into activity 6.3 and hopefully finish that up. Everyone's in first block seemed to be super okay with activity 6.3, and so hopefully it won't take us too long. As always, don't forget these learning goals that are in your textbook, you should pay attention to them. It's hard to know what you're supposed to know, or it's hard to learn what you're supposed to learn if you don't know what you're supposed to learn. So make sure that you can look at these goals and say, yeah, I can do that thing. If you can't, then you need to maybe go watch the videos on YouTube or find extra resources online or come to tutoring or something. And I will say, I did not get everything graded that I wanted to. That's because I think yesterday I spent 3 to 4 hours updating the YouTube videos to include the details about what we were covering during each portion of the video. Yes, ma'am. Right now? Well, she's working right now on an assignment she has to turn in. I was going to email Ms. Lightfoot later to find a good time, Tuesday, Wednesday, or Friday. Thank you. But please tell her thank you for thinking about it. Okay. What was that? Oh, so those videos are updated so that you can jump around. If you know that you're struggling with factoring, there was about 3 or 4 days, I think it was 4 days total, where we spent time on factoring. 2 days where I explicitly went over the rules of how to factor, and I've identified that. I think there was at least 10 problems where we spent factoring in class. And a student in first block noted last week, well, but Mr. Kinney, it's math. How do you study math? Or study for math? Well, it's simple, guys. One, you have to understand why things work. And after you understand why things work, then you need to practice making sure you know how to actually apply it. That's it. It's no more complicated than that. That's where the graphic organizers, the big idea graphic organizer is supposed to help, because you're supposed to have reflected upon and identified why these concepts work or how they work, and then maybe shown examples or identified where you can find examples. So make sure you attend to that as you're filling out those big idea graphic organizers. But that's it when it comes to studying. Now, as a quick, really important refresher, the number I, what do I mean by that? Okay, the number I is the imaginary number, but I mean, what is the number I? What does it equal? Square root of -1. Please be careful about that. There is something we can do with I to get just -1. What is that? I squared. Right? So remember, we defined I squared as -1, which is how we got I is the square root of -1. Right? Because the idea is that something squared had to give us a negative. Something times itself had to give us a negative. And so that's where the imaginary number I comes from. And then we started doing this card sort. And we already have these 17 numbers that are already blacked out. You already have filled in on your graphic organizer. In fact, you may already have some others filled in. So yeah, the blacked out ones are these right here that are already on here. If you finish sorting these early, what I want you to do is clearly define the rules for why those number sets are those number sets, or how we identify numbers that can fit within that number set. One thing I want to clarify or point out is this. if a number is a real number or it is an imaginary number, what's the big number set that we would call that? Say it louder. Complex numbers. And this symbol's not on there, but any guesses what symbol we would use for complex numbers? C, right? The complex numbers are, we use the C to identify them. Okay? One detail I do want to point out here is this stands for what again?
Irrational.
Which ones?
Irrational.
Irrational. Why in the world would this be irrational? What is this actually saying? If you look at those symbols. Q is quotient, but I'm talking about this. Why is this irrational or irrational? Say it one more time. So the Q is already being used, but remember, irrational, that prefix R, or IR, does anyone know what IR means? Not. So if you have that IR at the beginning of a word, it means not, and then rational. So it's not rational. So why is this not rational? And you were saying what, Chloe?
I'm saying it's real minus rational.
Literally, I have all the real numbers, and then I'm taking away all of the rational numbers. And so if I have all the reals and I take away the rationals, what am I left with?
Irrational.
Irrational. That's why we're using R minus Q to represent irrational, right? Because I'm taking away the rationals. Don't forget, most of these symbols are really straightforward: real, imaginary, whole, natural. Where did Z come from?
Germany.
From Germany. It stood for that German word Zahlen, which is just a number, but this is where we get integers from. And Q is way easier than it seemed on the surface. Does anyone remember what quotient what Q stood for? Quotient, there we go. And what do we do with a quotient?
Divide.
We divide, right? This is again what I kept harping on early in the year, and I know y'all thought I was crazy, but this is not 2 over 5, it is 2 divided by 5. It's a quotient, which means it's a ratio, which means it's a rational number, right? And so then there were rules also with the decimals. If that decimal repeats, it is rational. If the decimal repeats, it could have been written as a ratio. If the decimal terminates, it could have been written as a ratio as well. Okay, so here are the numbers that we have left to sort. We know how to start sorting these, correct?
Yep.
Any questions before I release you to continue sorting for the next 10 minutes or so?
Nope.
Let's get to work. They'll separate it down in the office, I'm sure.
The 2.3
How much is it?
is up there.
But I gotta find it.
Okay. But I think with National Honor Society, you're gonna have to take your records later. Remember, we've already did that. Hey Xavier, how much math are we doing right now?
I mean, you could do it either way. You just need extra.
Come on, man. I need you to actively engage. Let's go.
Shut up. You just like to don't participate.
Okay, wrong man.
Right, and things like
Negative 400. It's for negative 400 is imaginary.
I hear a claim. What's your evidence for that claim?
I'll get to it.
Okay.
We'll get it right.
Sorry. What's your claim? What's your reasoning? Your evidence?
Because you can't take the square root of a negative number. You get an error, and you can, but you have to use the properties of imaginary numbers,
Okay.
making it imaginary.
So, and that's one thing that we couldn't take the square root of a negative, but we now can. It's just an imaginary number. Say again. You talking about for here?
Then it could work.
So if it was negative square root of 400, that's a different story, right? Because the square root of 400 is 20, so that just be negative 20, right? That's not imaginary. But if I have the square root of a negative 400, and we're going to talk about how we simplify this later, but notice that's the square root of a negative 1 times what? 400. So this gonna come up later, but one of the properties of square roots and radicals in general is that you can actually separate those factors into two different square roots. Square root of -1 times the square root of 400, and so remember, we already defined that square root of -1 as
I, so you get 20I.
exactly, that's 20, and that's I. So it's not that the negative has to come, it comes out of the square root, we can rewrite it so that we get that I. Is that answering the question that you're thinking about?
That'd be one. Probably one issue.
There's some good discussions going on.
Yeah, one.
Any guesses? So why would I to the 0 be 1?
So, 0.97
Right now is one.
I thought it would be I powered to which one?
Except
I powered to
Wait, huh?
I powered to nothing. Well, it's I to the 0 power, but, and you hinted at this earlier, KT, that anything to the 0 is 1. So remember, and this is just using 2 as an example, what is 2 to the first?
The 6,
You'll be
Okay.
or
right.
2.3 is irrational.
So I'm gonna write that there for a second. What's 2 to the second?
2.389.
But how are you getting that for? Like, what do we mean rational exponent? Okay, but really, so like, just in general, an exponent is repeated.
Irrational.
The only decimals are rational.
But what are we multiplying by? Like, what could I start with here and multiply by 2 to get 2?
Wait, what did you
Multiplicative
say?
identity. Notice how that doesn't change the numbers. So you say 4, but 1 times 2
sorry.
times 2.
Okay, Dixie.
2 to the third then would be, which would, is coming from 1 times.
What?
So I'm just breaking it down and explaining where it's coming from. So as,
That'd be rational.
it is 3 times,
Oh,
1, 2,
you're talking about
3,
when I.
right? So that explains though, when I come to 2 to the 0, what am I still starting at? 1, and then how many 2's am I multiplying by? 0's, I have no 2's there, so I'm just left with 4. Is the best way to understand why something to the 0
I too.
is 1. So like I to the first would be 1 times I.
Because
I to the second is really 1 times I times I. Make sense now?
So y'all don't need me.
We had to learn together.
I said I too is an integer.
Oh, you?
Because I too
I like that.
I said.
Can I challenge y'all on something? You're on square root of -6 times the square root of -6. Where'd you put that?
Imaginary, wouldn't
No, that'd be, I.
Put imaginary, okay, why?
Now that you
it? So what?
So it'd be 2 times -1, like 3 minus 2. Or
Good logic. Hold on to that and have a whole discussion. That's a good question that we need to address. Okay.
Wait, what is the answer? Like, y'all confusing me. Don't start. Y'all don't.
Yes, all of them.
What? That's what the day was. I'm like, yeah.
Why not put 2 plus I times 2 minus I under the imaginaries and I to the 0 under the imaginaries? You put I to the 0 under
I had to
natural.
put on spring day.
You have it under imaginaries, so I'll write out and discuss that. I'll come back and check this. That's the hand up over here. That's the hand up.
I really got.
I see Sarver here. I see
If we
Sarver.
would have sorted it out.
Okay.
Or do I need to collect Sarver so they don't get shared in the middle of class?
To be lazy.
Smile or tell me you're lying to me right now. I need you to remember to do that before I start. Well, I will start collecting. And I will thoroughly enjoy your semester.
That's not going to work.
Is that clear?
And I haven't turned in.
Alright.
First day.
What's your question? Okay. I got a challenge for you. Well, first off, make sure 2 plus I squared, make sure 2 plus I is inside of parentheses. But I want you to read 2 plus I times 2 minus I, and the square root of -6 times the square root of -6.
Yeah.
I got like 9.
We
I came over to your group and you
No,
weren't
I
there.
think it's imaginary.
Busy talking.
Actual power of
So
zero.
that couldn't help.
It would just be, or
So,
zero.
Liam, did you just make some
Whatever.
numbers to fit into those different groups?
It's a whole.
Where did 7i come from? Because that's not the
Not imaginary.
Okay, so yes, you did make some. That's what I was just curious. Okay, that's fine. Okay. Alright, I do want you to pay attention as we go over some of these because I see some of yours. I see some definitely under the irrationals that are included. And help each other.
I mean,
Came this morning.
Oh.
It could be a whole.
So wherever that fits. That might be a thing.
Oh, I already had I0 natural.
Because you're just putting it in a calculator, right? Do you know why it would be an integer?
oh, that's imaginary.
Because you can't put,
And also, how does square root of -6 times square root of -6 become an integer when each of those is definitely imaginary? Thank you. Thank you. So I'm starting to see a handful of really good mistakes that we need to address and talk about, and some really good sorting in general. So let's learn and grow from these mistakes and become better mathematicians as a result. And so we're going to talk about some rules that we want to keep in mind. First off, I do want to point out this detail. Can you just immediately look at the number and always know where it's going to get sorted?
No.
So what do you need to do first?
Type it in the calculator.
No. So we don't want to just type it in the calculator all the time. We do need to be able to see it and think through, is it going to be, what set is it going to fit into? But we should also know why it fits into that set. Does anyone see anything on the board that might tell us what we need to do before we identify the number set?
Simplify.
Oh, look at the whole board. You have to simplify before classifying in the number sets, right? Okay. So I'm going to address a couple of these and talk through some, excuse me, some important details to keep in mind. I think there were 4 numbers that I saw that really sparked some debate or that I pushed on with different students. I to the 0 was one. I think we already did I squared, right? In class last week? So we don't need to do that one. I to the 0 is definitely one. 2 plus I times 2 minus I. And I will tell you some of these I'm going to tell you to write on the back side of this sheet so that you can have some notes to help you with simplifying radicals and the such. But let's look at I to the 0 first. Right away, it has an I there, so you might think what number set? Imaginaries, right? Okay? But is I to the 0 imaginary?
No.
Why not? Is it? So I to the 0 is what again? 1. So first off, is that just an integer?
Just a natural.
Now, is that an integer as well? Yes. Remember the way that this works is that you build up, right? I to the 0 is 1, and that square for natural number is nested within the whole numbers, so it is also a whole number, which is nested within the integers, which is nested within the rationals. Notice those squares are building into each other. Do notice that there is a more solid line separating the rationals and the irrationals. So is that number irrational? No. But it is real, which means it is also, what's the biggest grouping? Complex. Okay? So it all fits within those categories. I want to pay attention to that. Now, this did spark some debate or discussion of why in the world is I to the 0 1? And the answer cannot be I just put it into the calculator. We got to understand why. Why is I to the 0 1?
Because it's
So some of us do know anything to the 0, any number raised to the 0 is always going to be 1.
It's not another I. The 1 is multiplying.
Okay, so you're going into some of the background details that you and I discussed. So first off, I want to point this out. What I'm about to do is made up, right? It's not a part of these numbers, but it's to explain some of this. Please flip over your graphic organizer. The number says graphic organizer and make these notes. So details about powers. So, what KT is referring to is 2 to the first. Everyone knows this. It is 2. Okay. 2 to the second is 4. Where did that come from, though?
1 times 2 times 2.
Well, typically people, and I'm going to get to what you just said in a second, typically we just think 2 times 2, right? And 2 to the third would be 8 coming from?
2 times 2 times
Now what I want to point out, and I want you to remember is this. What is a positive exponent? Or a positive integer exponent? It's repeating something.
multiplication.
We're repeating multiplication, right? But even if I look right here, what in the world am I multiplying by? There is no multiplication right now. So what number are we actually starting at so that we can multiply by 2?
1.
Notice I'm using the multiplicative
Identity.
identity. That doesn't change anything, but it's 1 times 1, 2. That's why it's 2 to the first. 2 to the second is really 1 times 2 2's. 2 to the third is 1 times 3 2's. So what is 2 to the 0?
2 times
1 times nothing, or 0 2's. Notice it's not times 0. There are no 2's is what we're saying. So 2 to the 0 is 1. We've talked about this in the past before. This also explains why 2 to the negative 1, does anyone remember what that is? No, 2 to the negative 1.
I don't know.
We have talked about this. We did it when we did linear and exponential functions. It's 1/2. What's another way to say that?
1 divided by 2.
1 divided by 2?
Oh, yeah.
2 to the negative 2.
1/4.
Which is 1 divided by
4.
2
Oh.
times 2.
Okay.
2 to the negative 3. 1 divided by
6. 2 times 3.
2 times 2 times 2. So we want to notice when it's a positive integer, it starts at 1 and repeatedly multiplies. When it's a negative integer exponent, it still starts at 1, but what's it repeatedly doing? Dividing. Whereas 2 to the 0 just has the 1. You want to note that and pay attention to that. Though it's not random, it's not made up, there's a method to the madness. There's a reason why. Few divisions starting at 1. Or as a positive exponent. Repeated multiplication starting at 1. That's why 2 to the 0 is just 1. And notice that's just using base 2. You can use any base to explain this. But that's why I to the 0 is just 1. I'm multiplying by 0 i's. Okay?
Smart.
So hopefully we have that down. And we're gonna look at that 2 plus I times 2 minus I in just a second. From what I can see, everyone has at least these down. So I left the notes over there. So 2 plus I times 2 minus I. It's got an I, so what are we going to be tempted to put it under? Imaginary. I think I already told several people though to re-examine that. Anybody know what it actually fits under? Or what it would actually equal once simplified?
Natural.
Well, it's equal to 5. You can put that in the calculator as long as you have it set up for the rectangular coordinate system. So what should be the question you're asking right now? Say again. Oh, you're just talking, not asking the question? Okay. Anybody know the question we should be asking? How, right? How in the world does 2 plus I times 2 minus I equal 5? Anybody guess how I at least started to get there?
No.
Oh, how'd you get 2 times 2? So 2 times 2, anything else? Can you what? So I can't just take out the I, but 2 times 2 is 4. 2 times, so negative 2I or minus 2I. What property are we using there? Distribution, right? You could use the area model as well. Either one's fine. So now what? Kenzie? You awake? Just looks like you're zoned out, just looking at me, but not. You there? Any ideas what I'm going to do next? None? You have no clue how to distribute. Well, then you better pay attention and ask a question if you have this in a second. Chloe, what were you saying? Right, we distributed this first 2. Now we're going to distribute our I times 2 plus 2I. Then I times negative I gives me negative or minus I squared. Mackenzie, you good with that now? Jaquan, we just distributed and used the area model, if you would prefer to do that, last unit. Not even 2 weeks ago. It's not, dude. That's not. So what's going to happen from here? So I'm going to hold off on doing that for just a second. You are 100% right. Yeah, what are the like terms?
2I.
Negative 2I plus 2I, what is that? Oh, that's going to create a 0. Because what's negative 2 plus 2?
0.
0. Those would be called additive inverses, right? Creating that 0. So I'm going to write it as 2 times 2 for just 1 second. Actually, I'm going to write that as 2 squared. I'll explain why in just a second. Minus I squared. But what is 2 squared? 4. Minus, what's I squared again? Negative 1. Remember, that was the whole point, is that I squared is negative 1. What's 4 minus negative 1?
5.
5. Remember, when you subtract a negative, you end up adding. So 5. Questions, comments, or concerns up to this point? Okay. Let me ask you a really important question, because we did look at 2 plus I all squared. I think we looked at that one last week, right? Maybe? Probably. If we're not sure, let's pay attention to this. What does it mean to square 2 plus I? multiply by itself. Technically it times that 1 to start, but we're going to drop that off for now. 2 plus I. And so again, we're going to have to distribute. So 4 plus 2I plus 2I plus I squared. Like terms, what do we get? You sure about that?
No, 4I.
You get a 4I there. Yeah, we got to be careful. 4 plus 4I.
Plus I squared.
But what is I squared?
-1.
There we go. -1, right? And so 4 plus -1, remember that's 4 minus 1, which is 3 plus 4I. Notice, and KT picked up on a thing that he assumed, and we realized that's not quite right. That's a great assumption. Did that make a 0?
No.
No. So is it always going to create a 0 in the middle? So what's the difference between here and here?
They got added together there, I know.
When is adding
Yeah, we want to notice, because it's 2 and I in both of them, but up here one is being
this?
added, one's being
Subtracted.
subtracted, which makes those additive inverses. So we need to notice it's not always going to make that 0 in the middle, it's only going to make that 0 in the middle when? So only makes a 0 in the middle terms now you say when one's a positive and one's a negative, right? So let me give you a counter just to think about. Would that create a 0 in the middle? Huh? It's not the same values. So we need the factors to be the same, except one is, well, what adding and one is subtracting, right? So it's 0 in the middle terms when same factors, but one is adding and one is subtracting. Now, this is a very special case, something that happens not super regularly, but it can, and it's such a special case that we do have a name for it, and the name is based on this right here.
What to start with.
Well, I'm going to